In this lesson, we're going to do a little bit of analysis of these accumulation functions based on what we already know and based on our function analysis work from our derivatives unit. Okay, so this is an example of the type of problem we're going to see here. So given the function f, where f is the integral from -2 to x of this polynomial function of t, determine all x values for which f has a relative minimum. Okay. So this, like, the way this might work out in real life is, say t is velocity. We would be finding the time in this problem that we had traveled a minimum distance. Okay, so that you can keep in your mind as like the application of this, if that's helpful to you. We'll work through the example and then I'll give you kind of a review of the things that you need to know, because there were some facts about relative minimums, maximums, and concavity that you're going to find useful to review for this lesson. So f has a relative minimum. Okay, that means this occurs where f prime of x is equal to 0 and goes from negative to positive. Right? So from negative to positive means if the derivative is going from negative to positive, it means the function is decreasing and then increasing again. And this would be where the derivative is equal to 0. Okay? So our move here is to find the derivative, find these critical points where the derivative is equal to 0, and then make a sign chart. Notice though, the derivative is easy here. We're only doing one derivative. The derivative is this, right? So I don't really need to do any actual differentiation here because this is already an integral, so the derivative just cancels out that operation. Then I factor and I make my sign chart. So you guys are already quite good at this. So my x squared factors out, and I set that result equal to 0. So my critical points are 0, -6, and 2. And then I make a sign chart, and I want to make sure I go from left to right, so I'm going to start with -6, 0, and 2. And remember, the way I figure out my sign charts is by plugging in numbers. Okay, so I might plug in -7 here, and -7 would get me a positive times a negative times a negative. So that'd be a positive result. Okay. Then I plug in a number between -6 and 0. And a negative result. You can do this very quickly on your calculator if you struggle doing it in your head. This interval gives me a negative result. So I plug in 1, for example, I get a negative number. And then my last interval gets me a positive result. Okay, so now, again, I'm looking for a point where my derivative goes from negative to positive. Only one point here, right? That's this point, right? Because we're negative to the left, positive to the right. So I'd say that my function f of x has a maximum, I should say relative maximum, at x equals 2. That's it. So because most of you already mastered this previous work, adding in this work with these accumulation functions should be pretty easy. I'm going to give you a review of what you're looking for to find a max, a min, concave up, concave down, and all that, and then you'll be good to go. Okay, all these definitions were from our function analysis unit. So a critical point is where f prime is equal to 0. And then minimums and maximums are critical points, so f prime has to be equal to 0 at these points. And f prime changes sign, either from negative to positive or positive to negative. Increasing and decreasing, just go with the sign of the derivative, right? Most of you guys are very good at that one already. And then my remaining 3 have to do with the second derivative. So our inflection point is where f double prime is equal to 0 and changes sign. And that's where you change from concave up to concave down, which have to do with the sign of that second derivative. Okay, we will do, let's do a concave up, concave down example of one of these accumulation functions, then we'll call it a day in this lesson. So here is our example. So we want an interval where f is concave up. That means we need the second derivative, and we need the second derivative to be bigger than 0, positive. Okay. Well, my first derivative is easy, right? So that's my first derivative. My second derivative is going to be the derivative of that. So I'm going to do power rule. Okay. Do not make the mistake of thinking that this is your first derivative. This is your second derivative because it's an accumulation function. Like, this inside is not the entire function. I'm saying that and you're like, I will not make that mistake, but I suspect many of you will make that mistake at least once, which is okay. Just know to fix it when you run into it. So if you get one wrong in this lesson, I bet it's going to be something because of that. So we are going to set this equal to 0, find our critical points, and then make a sign chart. So I'm going to factor this. Oh, I'm going to drop my x here. Okay, so easy enough to factor. My critical points are x equals 0, x equals negative 12. My sign chart, we're going to go from negative 12 first to 0. And we're going to start over here, so I could plug in negative 13 or anything smaller. I get a negative result. Here, plug in like negative 1 or something, get a positive result. And then to the right here, if I plug in 1 or anything bigger, I get a negative result. You can check those on your calculator. I did those ahead of time to save us time. Okay, so we want concave up. So we'd say f double prime is bigger than 0 on the interval from negative 12 to 0. I'd say parentheses because we know at these points it's equal to 0, so those are not included. Okay, so it's concave up. Okay, so make sure you have a couple examples captured in your notes, and then you will certainly need what I have included here, so all these function analysis definitions. So make sure you capture those as well.